All right, folks, welcome. If you have flown with me before in the instruments and we've talked about holding, you have heard this before. If you have not, then you have not heard this before. But it doesn't matter whether you've heard me talk about this before or not. I think this is still beneficial. And I am a fan of, well, let me back up. If we fly together and we discuss something, and you're feverishly taking notes and writing down all the details, man, it'd be nice to be able to go back and replay that lecture, if you will, for lack of better terms. I mean, you've got the notes there, but if you could hear the descriptions and the explanations, etc., oftentimes there's better learning, which is what makes videos so cool, because I could hit pause, rewind, fast forward to the part that I really want to focus on, etc. And one of the cool things about videos, in most cases, is they're free, which means I can go and watch them over and over and over again. So the purpose of this is, and if you're watching this, you are most likely a student of mine, or we've crossed paths in the flying community, and I'm simply just sharing this with you. And also, I will add that if you've flown with me, talked with me about just about any subject, it doesn't have to be flying, I will tell you, I'm a simple-minded individual. I have to think in very simplistic terms. But what that has allowed me to do is break down things that can be somewhat complex, excuse me, challenging, convoluted, whatever. It has allowed me to, over the years, break down these things into very simple, understandable, conquerable tasks, and then tie them all together simplistically, and then go out into the air and execute them, or whatever it is we're doing, whatever project that may be. And in this particular case, we're going to talk about holding. Now, holding is just one of those things, and I am here, by the way. You're in my house. You probably hear my dogs walking around. If the phone rings, you'll hear it, etc. I'm drinking some hot chocolate. It just snowed today. It's nice and cool outside. Cold, actually. My feet are cold. I got my slippers on. But holding is one of those things that, you know, when you practice it a few times and draw it up, you go, okay, I got this. But if you don't do it for a while, it's like you got to go back to square one and study the thing. It is something that, quite frankly, you may never do in your entire flying career. Now, I say that with a caveat that if you are going to go fly, for the airlines, etc., you will hold. They're going to hold for weather. They're going to hold for winds. They're going to hold for gate times. Most likely not necessarily for gate times, because you burn more fuel holding than you do sitting on the ramp. But I have seen aircraft hold, like, for example, outside Denver's airspace, and a bunch of them, because the winds were so out of control at Denver on this one particular day. But as a general aviation instrument-rated pilot, you may never, ever, ever hold. But when will you hold, and when is it important? Your check ride. So, and it's one of those skills I think it's cool to have and be fairly good at it, and especially being good at drawing it and writing down instructions, even though you may not ever go out and do that. I think it's kind of cool to be able to pride yourself on knowing something darn well, being able to do something pretty well that isn't done very often, right? You can have great landings, but we all land all the time, and so what's the big deal? But we don't hold that often. But if you're good at this holding thing, then I think it's kind of chalk up a few points for pride. So what I'm going to do and talk about holding, I want to talk about first, just real quickly, the 6 tenets of holding. And I'm going to throw them up electronically on this video. I'm not going to bore you and show you my bad handwriting. But the first one is, we are always holding relative to a point. Now, that point could be a fix, intersection, nav aid, GPS waypoint, and incidentally, even though I said, hey, it could be a nav aid, if you are limited to TACAN use only, tactical air navigation, in the world of general aviation and civilian aviation in general, we don't use TACANs, but I'll throw out there the TACAN cone of confusion, and you're just going to have to look up what that is. I'm not going to tell you here on this video. Is very large for TACANs, and so it's very difficult to define when you're over the station. In fact, technically, you have to use when the DME stops counting down, but that is too inaccurate to use for holding, so you can't hold over TACANs. Just a little side note there. But that point could be a fix, intersection, nav aid, waypoint, etc. And when we say fix, it's typically a VOR DME fix. So a VOR radial DME. So for example, the 090 for 20 DME fix. So we've defined the radial, but that radial goes from the nav aid off to infinity. So somewhere along that radial, we're going to define the holding point. We do that by throwing down a DME. That's the first tenet. The second one, we will always hold inbound to the point. Always. And if I could get my dry erase marker, the cap is tight on there. So if that's my point, however it's defined, a waypoint, a fix, a nav aid, we always are holding inbound to the point. I'm drawing different scenarios here. So our holding course is the one that we're on when we're inbound to the point. It's not the one where when we're at the point we make a turn and we're outbound. That is not your holding course. This is your holding course. It's the inbound course to the point. And if that point is defined off some nav aid, forget the nav aid. The nav aid is simply to tell us what radial that point is along. And of course we use DME to define the point along that radial. But we're holding relative to the point, and we are holding inbound to the point. If you want to use like a little, the point of your pen or a marker or your pencil that you fly with, and use the pointy end, inbound to the point. Next tenet, and we'll cover all these as we draw up holding. Here's our point. Here we go. It's a right-hand turn. This is the protected side or protected airspace. This is non-protected. The 70-degree line, which we're going to talk about when we talk about drawing, that's the 70 degree off the holding course that we use to define that angle there, 70 degrees, when we use to help define what our teardrop entry options are. If you'll always remember that 70-degree line goes on the protected side when you do your drawing. Notice I didn't swing it over here to the unprotected side. The 70-degree line always goes to the protected side. Here's another interesting tenet. None of these are necessarily in order, but we're going to refer to them. And these 6 things, if you can lock them into your brain, they'll help you draw the pictures. If this is our point, here's the holding course. This is the protected side. I draw my 70-degree line, remember? And let's say we're on 090, so this would be 020 for 70 degrees off. If I draw that reciprocal heading, which we will when we do our drawing, this is half of your pie. This is half a circle. This is half of your cake. Whatever you want to, whatever analogy. I say pie, P-I-E. But if you'll remember, the direct entry method, in terms of what direction we're coming from, will actually be all these different directions. The direct entry is always half the pie. And it kind of makes sense if you look at it from a probability, slash statistical standpoint. All the options to come in here that exist, the odds of me approaching this such that a direct entry would be the best is the highest. Therefore, that's why half my options of all the 360-degree radials that I could come in here at from all these different directions, half of them will lead to a direct entry. A direct entry. Your next biggest piece of pie is your parallel entry, and I'm not going to try to spell that. I'm just going to put a P and an A and some scribble scratch on the end and tell you that it's parallel. Maybe I'll put an L there and convince you. Your next biggest piece of pie is your parallel entry. And again, from a statistical standpoint of all the different 360-degree options in terms of radials I could be entering here, roughly that percentage of my 360 ends up being a parallel entry. And of course, the smallest option left, Smallest piece of pie would be this guy here, and that's your teardrop. So the largest piece of pie goes towards the direct entry. The next largest piece of pie is for parallel, and the next piece of pie, which is the smallest, leads into your teardrop option. So now let's talk about, and by the way, when we're talking about holding, we're talking about unpublished holding here, right? If it's published and on paper, a lot of times the work's done for us. So I failed to mention earlier, we're talking about unpublished holding. So one of the tricks, by the way, if I haven't mentioned this to you before, and I don't mean necessarily in this video, but if we've flown together, one of the most important pieces of mission materials you can have with you in the cockpit is blank paper. Blank paper and something that writes well, that you could read at night, by the way. And it may not always be a thin lead pencil. It may be a nice thick line ink pen. But anyway, because you'll want to write instructions down, and this is one of them. So how do we write down holding instructions? Well, let me give you an example of a holding call, and then you ask yourself, man, am I going to write all of that stuff down? So an example would be something like this. And I use Diamond 405 Mike Alpha because that's a plane that I do a lot of instruments in. Diamond 405 Mike Alpha approach. Yeah, go ahead. 405 Mike Alpha. Yeah, we just had multiple runway closures, etc., and we're probably going to be down for the next 20 minutes. Would you prefer to divert, or would you like to hold? Yeah, we'll hold 405 Mike Alpha. All right, 405 Mike Alpha, let me know when you're ready to copy holding instructions. And of course, I'm getting my paper ready and putting the pen in hand, maybe hitting the autopilot for altitude hold, heading select, things like that in my cockpit, or handing the aircraft to somebody else while I'm about to write these down. Or if I'm single seat by myself, single pilot, then I'm just getting ready to do it. 405 Mike Alpha is ready to copy and holding instructions. So now listen carefully and ask yourself, how would you write this down? 405 Mike Alpha, hold southeast of the Black Forest, 130 radial, 20 DME fix. Left-hand turns, expect further clearance at 2230. 405 Mike Alpha, hold southeast of the Black Forest Vortac on the 130 for 20 DME fix. Left-hand turns, expect further clearance 2230. Diamond 405 Mike Alpha, read back correct. So how would I write those instructions down? Well, you told us hold southeast of. So I do this, hold southeast of the Black Forest, if I know the identifier for that. He said 130 for 20 DME fix. That's how you write a radial DME fix off of VOR. There's other techniques too. You may see 132, something like that. Computers will use that format because they don't like the slashes, etc. But we're writing, so let's write something that makes sense to us. Off the Black Forest, 130 for 20 DME, left-hand turns. What if he hadn't said left-hand turns? What would we do? It'd be right-hand turns because that's standard holding. And if it's standard, they won't say right hand. They'll leave that part blank, and it's assumed that you know what that means. Then they gave us an expect further clearance, so I write that down just like so. So when I get to 2230 Zulu and I haven't heard from them, or they haven't given me another clearance or more instructions, I will probably pimp them at, pimp them means, bug them at 2229, because I'm not waiting until 30. Well, I guess I will if they said expect further clearance, but at 22:30 and 30 seconds, I'm gonna ask them what's going on, because I'm sitting there renting a plane and paying for fuel. So that's how I write down holding for unpublished holding. Now the next step is to draw this bad Johnny. So if you remember tenet 1, we are always holding relative to a fix. Relative to a point. And in this particular case, we're holding relative to a nav aid, a radial DME cut, 130. And I'm going to get rid of the nav aid now, so it really doesn't matter. And we're going to talk about reciprocals. And remember, this is a radial, so I've drawn the little arrow there, but I'm going to get rid of it now because I don't want any confusion. And remember I said they said hold southeast of. So off this point, I have north of, south of, east of, west of, northeast of, southeast of, southwest of, and northwest of. They will only ever use 8 cardinal directions: north, south, east, west, northeast, southeast, southwest, and northwest. That's it. And here they told me, remember, we're always holding relative to the point, and they said what cardinal direction off that point they want me to hold. Tenet number 2 said we are always holding inbound to the point. So I'm going to get rid of this arrow here because I don't want there to be any confusion. I want now this arrow to be us, and in fact, I even brought over a different colored dry erase marker so we have no confusion between what's us and a simple radial line. Let's make sure we get so that's us. So we're holding southeast of, on the southeast side, if you will, quadrant, whatever term you want to use, of the point, the point. And in this case, that point's a fix, radial D me fix, and we're always holding inbound to that point. They said left-hand turns. Our turns always occur at the point. Now, I don't mean we're not turning anywhere else in the holding pattern, but when they say left turn, right turn, left-hand turns, etc., that I'm executing that direction turn at the point. So they said left-hand turn, so it'll be a left-hand turn. And of course, we're going to parallel the holding course outbound, and I'll just draw a racetrack pattern like so. And there we are in our holding pattern. So we've drawn the basic holding pattern, and it's on the 130 radial off Black Forest. Bueno. Let's draw now the reciprocal of that radial, and that would be a 310. That is the reciprocal of our radial that we're looking at. So what's next is to draw the 70-degree line. So we take our pencil, marker, whatever we're doing, and we put it just like it's us. Remember, we always hold inbound to the point. And we remember the third tenet that I gave you. The 70-degree line always swings towards the protected side of the holding pattern. And by the way, if you didn't know, protected side means there's no mountains there that you're going to hit. There's no other traffic, Victor Airways or something like that that's going to be a conflict. There may be a mountain right over here or restricted airspace or something. But the person who built this, a terpster is what they call them, built this at a certain altitude, assuming a certain maximum speed and a certain turn rate, i.e. standard rate turns, that if you execute all those standards, you'll remain protected. You won't hit the mountain, you won't hit the ground, you won't go face to face with the Boeing 747 that's on final approach somewhere. So back to tenet number 3, the 70-degree line always swings towards the protected side. And so here we are. So let's draw a dashed line. And it's going to be really over here somewhere. I don't want to draw that east of south. You can hear one of my batteries in the fire alarm thing, smoke detector that's going off. You know, why does it always do it? You know, it doesn't do it all the time. Like if I walk down there to try to find where it's at, it'll stop doing it. It's always funny. Okay, so third tenet, 70-degree line. I'll draw a little arrowhead here. So that's our 70-degree line. What direction would that be? Well, we add 70 to this one, so that would be 200. Pretty straightforward. Let's find the reciprocal of that 200 line, and we have the 0, 2, 0. So we've drawn our holding pattern, left-hand turn southeast of the Black Forest 130 for 20. We drew the actual pattern itself, that's us. We drew the reciprocals for our key lines here. And now we ask ourselves, well, what the heck's this teardrop parallel direct entry stuff? Well, if you'll remember, tenet number 4, it said half the pie is on the direct entry side. And how you remember which half, I didn't mention this as a tenet because it's really not one in my mind, but it's something I remember, is that half the pie, or the direct entry side, has the meat of the holding pattern. And by what I mean, the meat means the most of it, man. The meat of the pattern is on this side. Therefore, this is half of the pie that is allocated to direct entry. Now, I told you I use dumb, stupid pony tricks and simplistic things to remember stuff. Notice on that, but that doesn't mean all the holding pattern is on this side. And of course, it's not. It's right there. But the vast majority of it is on this half of our pie. Therefore, this part is dedicated, or is the direct, and I write a D, direct entry side. Direct entry side. Tenet number 5 said the parallel side is the second largest piece. So here's the first piece. Here's the smallest piece. Oh, here's the next biggest side, and I'll put a P. That's the parallel entry. Parallel entry. Then, of course, the next, the next largest, and of course it's the smallest overall, it's the teardrop entry. Teardrop. So now that we've drawn our pattern, now we just simply have to ask ourselves, how do we apply this? So let's suppose we're flying to our point, and we look in our HSI, DG, mag compass, whatever it is you're using, and I'm just going to pick a heading. And we're flying a 020 to the point. Well, that happens to be the radial itself. So let's pick something that's not on the radial. 030. So we're flying at the point, not 020, but 030. And guess what that means? That means any heading between a 020 and a 130, guess what entry we're going to do? Because we're coming from this side, that's the P, we're going to enter doing a parallel. So we're going to hit our point. Let me draw it in blue. Let me get rid of this guy, because that looks like that, looks like that. So we're going to hit our point, flying 030, and we're going to parallel the holding course outbound. We're going to parallel the holding course outbound. Now, if I redraw that holding course, of course, it looks like that. And that's why they call it parallel. In fact, I'll draw a little arrowhead to remind us that we always hold inbound. And we're allowed to do this. Now, we talked about this side being unprotected airspace. So you could look at this and go, oh, you're on the unprotected side. You're going to hit a mountain. Not really, because the terpster, the person who built this, knows that if you hit this point on any of these headings from 020 to 130 and not exceeding the maximum allowable airspeed for your holding pattern based on your altitude, and you at least fly standard rate turn. In other words, we can't hit this holding point here. Let me get the blue. We can't hit this holding point here and then rack up 2 degrees of bank to fly a parallel. You'll be all the way out here. You see that? So they know if you fly at least a standard rate turn in your airplane and not exceed the maximum allowable holding speed for that altitude that you're holding, well, guess what? You will be protected. And I will tell you my technique. If I parallel outbound, I don't like staying there. That's just me. I want to at least get back on the radial. Because notice, what will my nav aids look like? I will have a CDI centered up that's not the holding radial if I decide to center up a CDI. And if I have 130 or the reciprocal set up as my CDI course arrow, it will be offset. And to me, that just looks weird. So I'll hit this point to do a parallel entry, but I'll always come back to the holding radial or holding course, whatever term you want to use. If we come back, let's take this to a different extreme. If you want to, for the parallel example, let's say we're flying a heading of, and I'm just going to do it in blue so I'm not changing pens, a heading of 120. Well, then we're hitting this thing flying like that. And we will just simply parallel outbound. Again, I will intercept that thing. I get back here. I do a turn to the protected side. A turn to the protected side. And by the way, what direction turn is that? It's a right-hand turn. Oh my gosh, you broke the rule. The guy said left-hand turns. No, the left-hand turn applies at the point, the holding fix. We're not talking about turns back here to remain on the protected side or to intercept the CDI or the radial outbound, i.e. center up the CDI. Or even, you could, if it was a really shallow intercept right here, you could say, yeah, it's a parallel entry, but when I hit here, I'm actually going to teardrop. Because my technique is I want to be on course, CDI centered as long as possible before I get to the holding point. But on this particular case, I drew it like so. It's going to be a right-hand turn to get onto the protected side. Then I'll come in here, hit the course inbound. My CDI is going to be centered up. Here's my course arrow. There's my CDI. Here's the tail. Course head, and course arrow, whatever you want to call it. So that's going to be centered up. Now I hit the point. Now I do the left-hand turn. So now I do the left-hand turn for the holding pattern. So I've had students get here and make a left turn because it said left turn. And guess what they just did? They ran into a mountain and they failed their check ride. And they get to do this right over again for failing holding. If they're too close to the check ride with me, we're going to go out and do it again. So now we're established in holding. So that's your parallel entry. Let's go through a couple other examples. Let's suppose now our heading is anywhere from, well, let's just pick one. Let's pick a 180. So we're headed due south towards the point. Well, we're coming from the teardrop piece of pie, so we have the option of teardrop. Sure enough, we hit the point. We come outbound. And what am I really doing when I fly like this, when I fly outbound? I will draw it larger over here so you can see it. There we are. Here's the holding course inbound. I am building 2 turn radii, which is what? A turn diameter. That's no wind. So here's a radius. Here's a radius. So, and of course, 2 radii is a diameter. I want 2 turn radii or a full turn diameter away from that holding course. So you can figure out in your airplane at the altitude you're going to hold at what your ground speed would be, and of course what the winds are doing to you. And some airplanes, you don't have winds. All you can do is just kind of go to school and see how it affects you on the turn. And then by go to school, I mean learn what the winds are doing, to you on this entry, and then apply those in your next turn. The diamond, some airplanes actually have wind component vectors that will show them to you on your PFD. But the point is, that's the spacing I want from this course. And then I'm turning inbound on the holding course. And this is the teardrop, because it looks like what? Here's a teardrop, and here's an eye crying, or whatever you want to call it. Looks like a bird beak. But that's why we call it a teardrop. So any headings between 200 and 130, I could teardrop. I could hit this thing because my heading is 135, looks ugly, and then I would teardrop. And of course, I'd have to be more aggressive on my turn to establish that teardrop than this example here where I was 180. And that's your teardrop entry. And of course, the other one would be direct. And we said any approach to our holding fix from this section of pie, so from here, or from here is going to be direct. So this one makes sense. Look, I'm coming in here, I hit the point, and I just go straight to holding. I turn inbound. Now I'm on the holding course. I can adjust for winds. By the way, I'm starting my timing when I hit that point. So I had about 40 seconds for a 1 minute holding pattern. I'll turn inbound, hit this point, note the time, and then adjust it accordingly the next time I'm outbound so that I hit this thing 1 minute or a minute and a half above 14,000. So this is kind of straightforward, but look at this. If I'm coming from here, what do we do there? Well, that's a direct entry as well. And it doesn't look like it. It looks like the smart thing to do would just be to turn this way, but because we're initiating our turn so far away in terms of degrees from the holding course, you're not going to stay on that protected little piece of protected airspace that the Terpsters gave you. So a direct means we have to hit this point. So if our heading is 360, I take that back, 360. We got a heading of, let's call it I'm sorry. A heading anywhere from 200 to 020, my apologies. So yeah, 360 would work. Just stay with the program. So a heading of 360, we're going to hit that point, and it's a direct entry, which means we hit the point and we act like nothing. I mean, we do this crazy turn like that to enter holding. But just a little bit more this direction, 20 degrees, we would hit that point and go that way for a parallel. And that's your holding. So what we talked about were the 6 tenets of holding. We talked about using nomenclature, shorthand, whatever, brevity, whatever term you want to use to write down 405 Mike Alpha, hold southeast of the Black Forest, VOR 130 for 20 DME, left-hand turns, expect further clearance 2230. And then we talked about how to take these instructions, put down our point relative to the nav aid, and then figure out the 70-degree line, do our reciprocals. By the way, I'm going to do a separate video on how to quickly calculate reciprocals. Do our reciprocals, and then draw it up, and then look at, once we're pointed towards the fix, and by the way, I have a separate video on how to do fix to fixes. Now that we're headed towards the point, I can note my heading and then use that heading to determine how I enter holding. Remember, this section of the pie is where I'm coming from. So anything here coming from would be direct, anything here would be teardrop, and anything here would be parallel. And then we talked about actions we take once we hit the holding fix. Lastly, I will leave this with you, and a lot of people don't realize this. When we're coming in here holding, by the way, ATC formally does not care how you enter holding. They don't care about teardrops, they don't care about any of that. As long as you remain on the protected side, and if you happen to go to the unprotected side, you're using the parallel method because the Terpster has done the math for you and said you'll be safe, it's okay. So as long as you just enter holding according to the general rules we've talked about, it's okay. So if the heading would have been better to do a teardrop and you do a parallel instead, they're not going to freak out. As long as you adhere to the times, the air speeds, and of course, the turn direction. But the other thing is, when you hit that fix, you're not establishing holding. When you're doing, whether it's a teardrop, parallel, direct, like this, you are getting established in hold. I'm sorry, you're still entering holding. It's not until you turn inbound and you hit the fix again, now you're established. Now you're formally established. That's what ATC cares about. But 99.9% of the time, somebody comes trucking down here, they'll hit the point and they'll go, Denver Center, 405 Mike Alpha, established and holding. And Denver Center comes back and says what? Copy. They don't say, no, you're not, you're still entering. But formally, you're still entering. Just a little side note. So we talked about the tenets of holding, how to write the instructions using brevity, how to draw it up, how to fly the holding pattern, how to get your offset, what we're looking for, how to take winds into consideration, etc. And there's a lot more online regarding winds and holding, but that wasn't the purpose of this video. So I hope this was helpful. For those of you that are instrument students or want to be, I hope this helped. And if I am your instructor, I look forward to watching you apply this as you work your way towards aviation mastery. Thank you.